Okay, today we're actually going to learn how to solve triangles using trig, which will then get us to the coloring sheet that you may or may not have heard in the video before I edited it yesterday. So that was my mistake. But today we will get to do the coloring sheet. Alright, so the story yesterday of SOHCAHTOA and Falling Rock was all just to help you remember the mnemonic. So if you remember, it's SOHCAHTOA, where S means sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse, AH. And tangent equals opposite over adjacent. Okay. So then we're going to use those to solve these problems. I'm sorry, it's a little bit blurry on your document, but I think you can make it out. So we have our standard triangle with our lowercase a's, lowercase b's, and lowercase c's, and then the uppercases. So the sine A and sine B, just to remind you. Sine of A, so we're looking at that angle, would be opposite over hypotenuse, so A over C. Sine of B, if we're looking at this angle, would be little b over little c, opposite over hypotenuse. Now we're going to apply that to our numbers. So we have this angle here, that's our theta. So sine of the angle, sine of 80, equals opposite, over hypotenuse. That's going to be your setup for all of those sines. Sine of the angle equals O over H. So sine of 80 equals X over 30. Now, sine of 80, this is one number. It's a decimal. Let's see. Here's our TI. So you can see it. Sine of 80. 80 is that decimal, negative 0.99388. It's a number, so you can't separate the sine and the 80. You cannot divide both by 80 at this point. We need to get x by itself, just like we always do. So we're actually going to multiply both sides by 30. So I'm going to take 30 out front times sine of 80 equals x. Now, I could have changed the sine of 80 to this decimal right away, but if I'm going to do it on my calculator anyway, it doesn't matter. So I'm going to do 30 times sine of 80 equals. Oh, I'm in radians. I'm like, this should not be negative. Right here, do you see where it says radians? You see? Well, let me do it. Right there. Nope, right here. Up at the top in this menu bar, it says normal, float, auto, real, radian. I don't want radians. Mode. Down, down. We want degrees because we're dealing with, angles in degrees. Okay. All right, try that again. 30 times sine of 80. Good. We should never get a negative number. So x equals 29.54. Does that make sense in your drawing? Yeah. This needed to be less than 30. 29.54. So you just figured out a missing side using trig. Okay. Let's take a look at the next one. Same setup. Sine of the angle, which in this case is 42, equals opposite over hypotenuse. So same as before, sine of 42 is some decimal. Don't divide by 42. And we need to get x by itself. Well, when x is on the bottom, it's a little trickier. So first I multiply by x, so I have x times sine 42 equals 35. And then to get x by itself, I divide by this decimal. So x equals whatever 35 divided by the sine of 42 is. 35 divided by sine 42. 52.31. X equals 52.31. That looks good in the picture. Had to be bigger than 35. So this is how you solve for a missing side when you only know one side and an angle. Okay, cosine. Okay, and we remember cosine of capital A was adjacent over hypotenuse, so it's B over C. And cosine of angle B is A over C. The equation for cosine is very similar to sine. Cosine of theta equals adjacent over hypotenuse. So cosine of 32 equals 25 over x. And we have to solve for x. So multiply by x, multiply by x. X times cosine 32 equals 25. Remember, cosine 32 is just a decimal. Divide both sides by cosine 32. And then we're going to just do that on the calculator. 25 divided by cosine 32. And we get 29.48. 29.48. And that looks not good. Opposite. Oh, I made a mistake, didn't I? I put a hypotenuse over adjacent. So I need to do that again. And I only caught that because the calculator said 29, and that X spot right here, this can't be 29. It has to be smaller than 25. So that's how I double checked myself. All right, rewriting it. Adjacent over hypotenuse. Okay, so to get x by itself this time, I just multiply by 25 times 25. So 25 times cosine of 32 equals x. 25 times cosine of 32. Nope, come on. X equals 21.2. That makes much more sense in the picture. Okay, let's set up this next one. Our angle here is 35. Cosine of the angle equals adjacent over hypotenuse. With the x on the bottom, this is the one that takes more time. So I'm going to multiply by x. And then I got to divide by cosine 35. So x equals 30 divided by cosine 35. 30 divided by cosine 35. And I get 36.62. Okay, does that make sense in my picture? Yes, it's larger than 30, so we're good there. Lastly, we've got tangent. Opposite over adjacent. So tangent of A is going to be A over B, and tangent of B is going to be B over A. And the equation is tangent of theta equals opposite over adjacent. So tangent of 32 equals x over 12. Opposite of 32. So multiply both sides by 12. 12 times the tangent of 32, just some decimal, equals x. 12 times the tangent 32. So x equals 7.49, but that rounds up, so 7.5. And the last one, tangent of the angle equals opposite over adjacent. Again, with the X on the bottom. And yes, you're going to start seeing this a lot, and you're going to get used to the pattern. So you can start doing steps in your head if need be. So I'm going to do 17 divided by tangent of 43. $18.23. Okay, that looks good because this can be the smaller side. Okay, so that's how you solve for a missing side in a triangle when you know an angle measure and you know a side length. You can do trig with 30, 60, 90 triangles and 45, 45, 90 triangles also. But know that you're going to get a decimal from your calculator. You're not going to get simplest radical form. So it depends on what I'm asking for at the time. Okay, so today we are going to do that coloring sheet that's attached. And hopefully we're in school because I'm making this the night before. I will see you at the meet.